So the topic of core data, a very talked about, exciting topic. That's what we're trying to do. Where we left off before the break was we added this number here. And what we want actually is to be able to display an index, a count of, as the ID. That's what we want. So what we have done is in our create function, we hard coded this number 5. Now, if we, let's say, instead of 5, we want to use the number of items that currently exist, right? That presently exist. How will we get that? Let's say we just want to use that. How do you get access to it? If you had access to an array which was all the items, you would just get its length, right? So we do have that array. It's just that it's not here in content view. It's in master view. There is this array, events. And if we want to use its length here, we need this array over here. So just like we have an environment object declared in both places without having to be passed, what we can do is we can duplicate this request as well. We can do a fetch request here, and it will give us the events object in this scope as well. And then here, instead of ID, we could just say events.count and expect it to complain because it's in a closure, this action. No, Michelle, we just started. So what we are trying to do is instead of this hard-coded 5, we want the current number of items in the collection to be displayed here as the ID. So basically what we want is the count of the current number of objects. So this current number of objects is only available in master view. We have moved it, copied this code here, lines 48 to 51, this fetch request, and duplicated it here. So this gives us the events object, and what we can do is in our function call where we had hard-coded 5, we instead of 5, we now say events.count. As soon as we say that it is going to complain that this is in a closure, requires self dot, so just say fix and it will fix it. Okay, so now what's happening is create function is inserting a new object in the context with this ID. Let's run this and see what happens. Okay, now when I say plus, I want to see whatever number is there. There is 8 here. I want to see 8 and then so the current count. So it starts at 0. It's indexed starting with 0. You could always say count plus 1 here and it would give you the next number. But the idea is the same, and this 8, 9, 10 should get saved. So let's verify that. Doesn't let me. Okay, there. So yes, it is being saved. 8, 9, 10, whatever it is being saved. Now a question for you. This is not exactly related to core data, but an important one. How do we see we have got the same query being run in two places, fetching request. How do we avoid this duplication?
So maybe we can put in the environment object.
Absolutely. That's one way to do it. We can put it in the environment object. Another way, let's say we don't want it in the, for some reason we decide it's only one time here, we don't want to do the environment object. How would you pass it from here to here?
Passed by parameter or state.
Yes, we can do that as well. Or what we can do very simply is here, right? This request, entire thing, we just say var events. And over here in the master view initializer, we just have to pass it. This is how Swift UI works. Type annotation missing in pattern. So I have to give it a type. Let's see if this is just an invalid complaint. No, it is not. So, okay, I think this is what it wants. Still doesn't say it. So basically, this events is an array of events. Do we give it its type? Ah, okay. My mistake. So what it is actually it's not an array of events. It's an object of type fetch results, and each result itself is an event. So all we need to do is just duplicate that here, fetch results event. So that's what it should resolve itself now. It did. So we are passing whatever values we want to pass from here, we can pass to the child views like this. This is another good thing to know about. So you don't have to also all the time be pushing things into the environment. If it's like, going from here to here only, it's okay to use this. And you will see that this is different from in general how you create a new class, object of a new class. You have an init function that takes those arguments and creates a new object, right? In Swift UI, it works a bit differently. Whatever is your first declared variable here is what you're passing. And this name, this label should match this name, variable name. That's the idea. So this way we can avoid running the same query twice. And it should still give us the same functionality. Okay. So everybody got it up to this point. You can see your index is changing. And in fact, what I'm going to do is I'm going to delete the app and rerun it, start it. And to make it look nicer, even in this create, I'm going to add a +1 to it. So it starts with 1 instead of 0.
Mine is giving me an ID, a problem with master view events, events. It wanted an underscore under there.
Have you got this line in your master view? Line 48.
Oh, I have it, but I have the fetch request above it. So we delete the fetch request.
Yes, yes.
Okay.
Otherwise, you're passing an variable without a name. So that's why it would accept it if you put underscore, but it won't do the job.
Yeah. Okay. Now it's looks okay now. I haven't run it yet. Try.
So now I've got this set up so that the IDs are being generated and used. You should all be at this point.
I'm still getting the 5. I don't know. Do I have to like close the app?
You have to uninstall the app from the simulator.
Okay.
Yeah, you have to uninstall it, delete it from the simulator, and run it again. And if you're still seeing a hard-coded 5, you need this line. This line 35 on my code. The ID, if it says 5, it will assign it 5. But if you use the actual count plus 1, it will use the next index.
Now it's working.
Very good. So this is what we did, and I don't know if my next point is already example 2. But so look at what we did. We started off with a project just to see what core data does. We started with this one where there is no core data. And in this example, we saw that when you close the app, kill it, and restart it, nothing is saved. All the data just, it is in the memory, it goes away as soon as the app goes away. And then we created the same app with core data, and the data we saw was being saved. And then we understood why that was. In our first example 1A, there is no functionality to save the data. Whereas in the example 1B, we saw a bunch of these files. We saw this data model, which has entities and attributes. Originally, it had only one attribute, timestamp. We added the integer, the ID. And this data model, through all the setup here in the app delegate, there is the container which houses the context. That is passed along to the scene delegate. And this context is what is put into the environment. So any of our views within the content view can read data from this, bind it to whatever the view element they want to bind it to. And that's what happened here. Content view is binding. So through this environment object declarations, it gets the context in all of these wherever it needs it in master view and here. And what it does is it uses the event, the collection of events it gets from that context in here to build the list. So the whole thing, it's a closed loop. Anything you do here, it appears here. You make changes here, it appears here to the data or to the view. And we have to add new elements. We extended this event class that was given to us by Xcode. We as an extension, it creates a new object and saves it. So basically, it creates a new object of its own type, which is event, and it sets the ID and the timestamp, and then it tries to save it. Similarly, there is a delete function that gets rid of an object from the collection. So this is what core data is allowing us to do. The amount of implementation we did, what we added as a functionality for the ID was just a few lines of code. We added it here, we added it to the function declaration, and we added it to the function call, obviously, and to where it is being displayed. So these were pretty much the only changes that were needed to add more data to the model. So if you were building, like the example I gave before, a notes app, you could take this and add more, like just like I described earlier, add a string class, a string attribute in this model called the note content or something like that, and whatever else you want to store along with it. And just make the same changes we did now, and your notes will start getting saved and loaded. That's how easy it would be to create a Notes app.
I have a question.
Hmm.
For the attributes, do they need to be all lowercase in the core data there that you're looking at?
Very good question. Actually, that's a great question because entities all have to be starting with an uppercase. If you try to create an entity, let's say we say add entity, right? It's added a new entity. It's called entity. Oh, this is our event. This is entity. It has nothing. So if I change its name to entity with a small e, it's going to complain. Name must begin with uppercase letter. So that's for entities. So let me just first get rid of this because we're not using it. And over here, I have not tried it. Let's try an attribute with a name must begin with lowercase letter. So yes, the answer to your question is yes, Michelle. That one I was aware of. This one I had not tried. So, but we know now.
Is it because it's for database type storage?
It's a convention, really.
Okay.
It's just a
I
convention
think
that
databases only want lowercase and underscores, correct? Usually, the ones I've worked with, anyhow. That's been the format.
So could be internally, core data internally uses a database. It's basically a MySQL. It's an SQLite database internally. I don't know if SQLite has any such restrictions, but MySQL databases in general don't care about the case of column names. You can have all caps, you can have starting with a cap, small cap, doesn't matter. But yes, some characters are not allowed, so maybe spaces or minus or things like that may not be allowed. But here I think it's just their convention. Okay. So we've got up to this point where we have done this. Now we will build a core data model from scratch. So this one was like, we are going into the deeper end of the pool now. We started with a core data model given to us and we added functionality to it. And that gave us an understanding of how the whole thing works. Now we will build our own. So this time we will start with a single view app. And what we want is both Swift UI and core data to be enabled. And we'll see what happens with that. So let's start that. Start a new project and choose the single view app template this time. And you can use I am using the initial single view SV just to differentiate it from the master detail app. And our user interface is Swift UI and core data is enabled. Now let's create this. Okay. So the content view, if you were to create another application, which we won't, 2A, 2B will not do that. I'm just going to assume that we know enough about it by now to not have to create it. You will see that there are some differences. This file would not be there without core data. This one, the name of your app, .xc data model. This won't be there. And this would look exactly the same though. So even though it has added a core data model, if you go there, you will find that there are no entities, there are no attributes. It's a blank sheet. And when we run this app, what do we get? We get a simple hello world right in the center of the screen. That's all this does. App delegate because we added core data, it added these functions. Save context. And this is where we see this lazy var comes into play, because we are not using it anywhere. It is not going to be executed. We have no data to read or save right now. All right, so this is our app. What we will do is, what we want to do is, we want to, yes. So there is a, in the other uh, example, you saw that it had added this event.swift, right? With these two functions already there. We did not create them. Something to add a new value to the collection and something to remove an existing value. It gave us these two. In our current example, there is no additional Swift file because there is nothing in the data model. It doesn't know what it has to do. Okay. So what is this app going to do? Functionality. We will put the hello world in a V stack and add two buttons to it. One to add something and one to remove. The add button will add a data point to the core data model. Remove will remove the first data point. This is the functionality which we will implement. But right now, let's just go ahead and do the add and remove buttons in a V stack. So over here, put this in a V stack. And oh, here is something interesting for you. Yesterday, when I was trying it, I wanted to drop the buttons from this library. And I don't find them. Anybody run into this before?
You mean you try to find the button library?
Yeah, so yes, the objects, and I want to just drag and drop a button here.
Because I normally just type in, and I don't do the drop, so I'm not sure.
Yes, yes. So that, of course, we can just type it in. Uh, the advantage with the button is the dropping it is that it gives you all the action, all the closure, etc., right? So you know what all you need to do. Yours is showing, mine is not. So if you see that your that object library is not showing all the views, it's because your editor is only, the editor is open, the preview pane is not open. So now you enable the canvas if you run into that. It's just FYI. And now when I say plus, there are two more items here, views and something else, actions, modifiers. Okay. So now it came here. So I'm just going to add a button, and this is the add button. And I'll add another button and call it remove. Okay. And we'll run this, and this will give us the function, the sort of the hooks into the functionality we want to achieve. So there is add and remove, which don't do anything right now, and hello world is still there. And like before, we've done this before, we can add some spacing to this. Let's say we want 30 points of spacing between each object in the stack. All right. So this is the functionality in the view. In the data model, what do we want to do? We want to create an entity and then start working with it, connect it to the add and remove buttons. So let's see. We'll create a new entity and we'll call it item, and we'll add two attributes to it, item number and name. So in our data model now, we will add an entity. So go to this file, XC data model, add an entity and rename it item. And then we'll add attributes, one called ID and the other one called name. So imagine this is like a shopping list or something, right? And they can both be strings. Whatever type you want to choose. Here you have the freedom. We are just going through this to learn how to connect all these dots. So this is how you will do it. You define a data model. If you want to define more things, by all means, description, price, whatever you want, you can do that. This gives us objects of this item class. This is now going to be built for us by Swift, right? By this core data framework, it's going to give us access to an item class. Now, when we, just like here, in this, we have an event.swift and we extend this event to allow us to add new, right? The same thing we need to do for our new items. We can follow a very similar method. This file was, they called it event.swift. Swift is not very particular about file names matching class or whatever is in the content, like Java, the file name and the class name must match. Swift is not particular, but it's a good policy. Event.swift has something to do with the event class. So for us, we have an item, we'll create a new Swift file. So right click on this code folder, new file, and we'll create a new Swift file, choose Swift, and we'll call it item. This is where we can do whatever we want with the item, the core data item entity. So what we want here is we want the same create and delete functions, right? As we had in the other place. So you could, of course, do it all manually, type it up. What we are going to do is we are going to bring some code from the example 1B, our core data master detail, to facilitate and then make changes to it to fit our purpose. So what code are we going to bring? We are eventually going to do both insert and delete, create and delete. So we can just copy all of this. In fact, we should copy these two imports as well, because without importing core data, some of these objects will come up as undefined. So copy from line 9 to the end. And paste it here. And it will give you a bunch of complaints. It's fine, we'll deal with them. First thing it is saying is use of undeclared type event. Yes, we don't have any type event, not even implicit. Our type is called item. So we'll say extension of the item class, not of event. Right? And now it is complaining that item has no member of type timestamp, and we declared our ID as a string, so it cannot assign value of type integer to type string. So instead of a timestamp, what have we got here? We've got a name and an ID. So these are the two fields we need to assign in our item.swift. So instead of timestamp, we have a name and we have an ID, which is which are both strings. So over here, we need to pass it those two values, string, the other way around, pass a name as a string and ID also as string. And then we change this new event dot name equal to name. So what the property in the object is being assigned the value of the argument that is coming in. Same thing here. So now this function will create, whenever we invoke this function and pass it these two arguments, name and ID, it will create a new object, save it to the core data model. This is like your insert into table equivalent if you were working with databases. Except that if you were working with a database, you will not have the binding that it does automatically for you. So that's our create. In the delete, we have very similar problems. Event, it does not recognize because it is actually an item. That should be it. This here was because it was this item you were trying to delete was of a different type than what is in the collection. So that's it. These two functions will set us up. And so this is like an insert into table. This is delete from table. You could have other functions. Instead of create, you can have an update, which takes some of these arguments, and then you would be, retrieving some object from this managed object context and updating it. Or because there is property binding, you could just update it in your view and it will be done automatically on the other side. All right, so we have now, what have we done? We have added, we've basically created a schema for saving our items, what they are. We have code to insert an item. Now we are going to use it in our content view in this part here, where we say add, we want to use it. But how can we use it? Is it available here? Where is all that environment object and fetch request and all that? That's all missing. So we start setting that up now. So what we need is we need to see that in the scene delegate, the managed object context is being put into the environment. Yes, it is. Right? So we now need to, from the environment, get it into our content view. So that's the first thing we will do. Here we'll say at environment, and actually let me refer to the right syntax because I don't remember it offhand. The syntax for at environment, okay, you specify the key in the brackets and then you specify the variable name. So, and the key you always specify the slash backslash and dot. Managed object context is the name, and we'll call it context, just like that. So this is now pulling the data from the environment. We've got the context. And over here in the add function, now we can call the create method of the item, right? So we choose this, and this first argument is the context we received from the environment. So we will say context, and the name right now it's just an example. I'm going to give it a name of new item and an ID, again a string, just ID, just like that. Just like that. These are actual things you could be changing. You could, for example, have in response to this action of add, you could pop up a dialog and ask the user, what is the item name? What is the item ID? And use those values. Now, that is not our objective today. You have seen how those things work, alert dialogues and retrieving values. So what we will do is we'll focus on the core data aspects. So we'll just assume, let's just pretend that this is what the user entered, and maybe our user is repeatedly going to enter just this. And now here it's saying reference to property. This is in a closure. By now we know that it's looking for a self dot. So far, so good, right? But if you run the code, nothing is going to change in the view. If I were to run it, it should compile and it should run. And if I tap on the add, I'm going to tap on it 3 times, okay? And there is a reason why I'm telling you 3 times. 1, 2, 3. I have tapped on it 3 times. Nothing changed on the view, but this create should have been called 3 times and the 3 items added to my database. Now what we want is we want to display those items. So just like for the list, there was a for each and it did the part where it builds the list with text. What we will do is instead of building a scrollable list with navigation objects, we'll just display them one below the other, all the items on this page. So in the VStack, we want to add as many texts with the name and ID as there are items. So to be able to do that, just like before we had that fetch request, right? We need a fetch request here. And what we need is we need to get the list of items. So fetch request, if you look at the documentation, we saw earlier there were some options to sort, etc. So what it does is it will give us, okay, this is not very helpful. Let's go to the tutorial kind of documentation. So this is what fetch request does. The type of entity you are retrieving, sort descriptors, and then it returns a list in fetch results. So this is exactly what we want to do is we want to specify what is the entity, what are the descriptors, and if you don't give anything, any descriptors, whatever is the order it retrieves it from the database will be returned to you. So we need to specify entity and sort descriptors and then declare our variable. So fetch request entity is our item dot entity. This is what we want, each type, and this sort descriptors are empty. We are not asking it to sort anything. And what is it returning? It is returning, and they normally put the property wrappers on one line and the variable on the other. That's the convention, although I've done it here on the same line. And we'll call it items of type fetched results, and each result is in itself an item. Oops, not element, just like that. So this fetch request is executed when your view comes into being. This is pulled from the environment and this request is dispatched. And this is again asynchronous and the results come here. And this fetch requests, it creates a binding. So wherever you use this items object, it is bound to that. Now we can show all of those items here using a for each. Now, this is a simple example. We are using just, we're retrieving all the items and showing it. You may have, for example, in our previous case, if you had this, like we have that same app in core data, when you go to the detail, you may want to retrieve all the details of just this object of the entity, event entity in that class. So if we have a detail page for items, we will retrieve all the details of that item. It could be an image, it could be other things. Let's say it is a shopping app, local, although you will probably be working with data in the cloud. But let's say it's local. You just got a limited list of items the user has access to, and they're all locally there for them to add to their shopping cart. You may have things like pictures, description, other details, like shipping weight, size, etc. Those things may not change. So you will retrieve that object and display it. Here, what we want to do is we just want to put everything in a for each, and for each, which one are we going to use? Data and ID, those are the only two we need. So I'm just going to say data items. This data label is not necessary. So what this does is it creates a for loop which iterates over items and unable to connect. Okay. These intermediate errors you get when you're typing Swift code, just ignore them until you have typed everything. It's looking for something here and it starts complaining right away. Okay. So here we'll say, let me just say for now item. Obviously, I have a syntax error here. For each, okay, because the closure needs to receive an argument. That's the problem. So over here, we'll say item in, and in the text, we can display our properties of the item.id and item.name. And it should complain, okay, value of optional type string must be unwrapped. Yes, we need to put an exclamation at the end of both, because either of them could be null. Any of those attributes that you have in core data, if they're not defined, only one of them is defined, the other one is not, it could, be null. But in our case, we are saying everything is defined. So this way, what we've done is we have now, so far, we have created a new model. So whatever your app you are working with, you will create its data model like this, using entities and attributes. Then you will, for each of those entity, you may want something to be done when you're creating a new item or when you're removing. Maybe you need something to update the item. All of those will go here. Whatever the name of the entity, .swift, that's a good convention. And then in your views, you will follow this way of doing it. You will fetch the object from the environment and fetch either all of them or an individual item. And within your view, you will have all the binding available to you to display them, make changes to them, insert new items, We haven't yet implemented the delete, but let's see if this now shows a change in the view. This is why I told you I was counting. I will tap on the add 3 times. I had added 3 items to the database internally at the time, and it had been successful. So those 3 are showing up here. Now, when we say add, it will add another item. So the process would be, once again, the add button triggers this function item.create. It goes here to the item.swift. It runs this create function. It is receiving the name and the ID. So it creates a new item of type item and then saves it to the context. It's telling it save this entity, take this new object of the entity called item and save it. And it saves it. And as soon as that is done, due to the property binding, this gets updated. And when this gets updated, this gets updated. So that part we didn't have to do, right? We didn't have to say, okay, after you create this item, add it to this list. That we didn't have to do. If you are working with another way, with model view controller, it would be up to you. Say, okay, item creation successful. Okay, now update this view with the new item. You would have to make that explicit function call. However it does it is up to you. So let's add a fourth and a fifth. So far, so good. You guys are with it? Good, good. Now let's implement the delete action, and then we will be done with this example as well. So to delete, what we have is we we call this function delete at and pass it an index set and the context. So I do believe that the delete you just call directly. Let me just make sure that that's the case. Okay, you're deleting from the collection. So you will use this object, not the item, not this single item in the loop, but the collection we have received. So that's what we will use. So what we do is our collection is called items. So we are just going to say items dot delete. And this is what our method signature is delete at index and ns managed object context. So at index where we said we are going to delete the first item. So you just say a 0 in an array. And this is the context we have received. So again, the same thing about closure, that we've not used self twice, we have to use it. Okay, and this indices, even though there is only one, we have to put it in an array because it is expecting an array, not expecting a single integer. So now add and remove should get rid of one. So the same process as happened in add is happening here in terms of how the view is getting modified. When you say delete an item from this collection, it goes here to this extension of the collection, deletes that item, and then saves. So managed object constant or delete which item, whatever was passed in this indices array, all those will get deleted. You could, by that token, you could here, you could say delete 0, 1. It will delete 2. But if there aren't 2, it will probably complain, will throw an error. So now this remove should get rid of 2, which it did. Okay, so that's what is happening. It gets deleted from the collection, gets saved, and due to the property binding, again, this gets updated and this gets updated. So this is again also a reinforcement of the model view model. How the view model, and like I said last time, that view model is the behavior. We don't have a class called view model. We don't even have a class called model here. Well, actually we do. It's the core data model. But the behavior, that one thing changes, the other one automatically changes. Okay, everybody got up to this point? Excellent. So, uh, where were we? So we have done this. This again we have done. These are just reminders for me to make sure I cover everything. We have implemented the environment, we retrieved the list, we added text views and action for add and remove buttons. So this is core data actually. It there's because there are lots of bits and pieces, it is a bit, the learning curve may seem to be steep, but hopefully this exercises we did today, it gave you a good understanding of what it is. When somebody now says to you, oh, we are using core data, you immediately you should know that, okay, yes, they have a core data model, they have entities with attributes, and they have bindings. So the way it is happening is they update the data model, all these things you are now familiar with, that this is not a black box. This code here, the way it appears, it's not a black box. You know that this is where the data model is, this is how they are implementing their queries, and also how the whole thing gets instantiated, how it works, the context and everything. So that element of mystery should go away. And I hope it has gone away. Because it is very powerful. If you learn to use it, it's very powerful. In fact, the Apple engineers, they claim that it can cut your data storage related code by 50 to 70%. That's how much benefit you can get out of it. So the one exercise we didn't do, but we could have, is instead of using core data in our this last example, we could have said, okay, let's save all this to a file or a plist or whatever. And then imagine all the code you will have. You will have something that writes to the file or something that reads from the file and manages all the transactions. All of that we didn't have to do. Yeah, and the property bindings, automatic property bindings, you don't have to worry about, uh, you know, updating your views as your data changes. So any questions before we move further?